Welcome back my dear friends, a very good morning, good afternoon, good evening to all of you. And as you know, this is the DADM, which is Data Analysis and Decision Making, one course under NPTEL MOOC series. And we are, as you know, this is a 12 weeks course for 30 hours, total number of lectures is 60, and that is each lecture being for half an hour, and each week we have 5 lectures of half an hour each. And after each week you have assignments. So, we are now in the 47th lecture, and we have just started about considering the utility theories in the last 3-4 lectures. And by the way, my name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing about utilities for decision making, and whenever you are making a decision, your main idea is to basically try to find out the so called expected utility. That is a notional concept based on which a decision maker will proceed. And when you are making a decision, we said that in order to basically compare the decisions based on the concept of expected value, we will take a certainty equivalent. Certainty equivalent means that value in units of wealth, whatever the units of the wealth is, that corresponding utility based on that certainty value of wealth would give you the same value of utility, of same sense of liking or dislike. I will not use the word disliking, liking, such that the gamble or the lottery or the uncertain event which is there on the other hand would give you the same value, such that you will be equally disposed between both of them, which means the expected value based on C, which is basically a sure event, and the expected value for the case when you are trying to basically consider a gamble or a lottery, those basically should exactly be equal, and that is why you will basically have the certainty value. Now, when you are considering the certainty values, I will draw it and I will basically explain it in more details within few minutes. So, but first let me discuss. Consider you have a set of a gamble or a lottery or an uncertain decision on one side of the table, and consider there is a fair gamble, in the sense there is a coin which you toss is an unbiased coin, probability of head is half, tail is half, and based on that you get some outcome as W1 and W2. And obviously, based on W1 W2 you will basically now formulate your own utility, which would be corresponding to W1 would be UW1 and corresponding to W2 will be UW2. Now, if I ask you what is the expected value, you will basically multiply UW1 multiplied by half plus UW2 multiplied by half, and basically find the expected value of the gamble or the lottery. Now, on the other side of the table there is a fixed value, in the sense fixed value in the sense that value has a is based on the fact that the probability is 1 because there is a sure event, and that value is C. So, if that value is C, obviously the accrued utility for you would be U of C. Now, if I want to find out the expected value of U of C, you will basically say it is very easy because it is a deterministic event. So, you will basically multiply the corresponding probability is 1. So, your total utility will be U of C. Now, in case if both of them give you the same net worth, in the sense same sense of liking or same sense of values, in that case I will be equally disposed or equally have a equal level of liking or disliking or indifference between both the gamble, which is one side of the table, or the lottery which is on the one side of the table, and the certainty table which is on the other side of the table. Now, say for example, if another person comes and the person basically has a liking for the lottery, which means the person is willing to take the risk, and the values are same, they are not changing, it is W1, W2 and the value is C. But now you will be asking that why did not I mention about UW1 here, because the main fact remains that the utility base for the second person would change, because his or her perception of the lottery is now totally different between this lottery and the certainty event. That is why he or she is willing to take the risk. Consider that the third person comes, and in that case the person is willing to take the certainty event, not the lottery, which means again let me again reiterate, the values of W1, W2 and C are same. Probabilities obviously are half and half for the gamble, which is the fair gamble. but the corresponding utilities for W1 and W2 for the third person is totally different. What was there for the first person is also different what with respect to the second person. Hence, he or she, that the third person will be more inclined to take the certainty event, because the person is basically not willing to take the risk. So, in that if I talk about the qualitative perspective of the risk perception of the three human beings, of the three persons, I would say that the first person is risk indifferent, because he is neither willing to take the gamble or not willing to take the certainty event. The second person who is willing to take the risk is basically is a risk lover person, because he is more interested to take that value of the gamble such that he or she thinks that in the long run the overall net worth of that gamble is higher than the certainty event or certainty value which is kept on the table. I am using the certainty value as a word, but it should basically be the value of C which I am talking about. And in the case if the person is willing to take the value of C, which is the deterministic event, in that case the person is not willing to take the risk, hence is basically a risk hater. So, if I basically try to draw it, so let me read it what I said, and then I will basically be able to draw it in much more details. So, a risk averse person will select an equivalent certain event rather than the gamble, because he is trying to run away from risk. A risk neutral person will be indifferent between the equivalent criteria event and the gamble, while a risk seeking person will select the gamble rather than the equivalent certainty event. So, let me draw it, so it will be easy for you to understand. So, consider let me draw the diagram first. So, with the black color. So, this is 1 and this is 2. This is W1, this is W2, this is half, this is half, this is a value of so called, let me consider it C. So, the equivalent utility would be, I will denote as U of W1 and the equivalent will be U of W2. Then the equal one, this is probability 1, equivalent will be U of W C, sorry. So, this is the scenario, and then I will basically draw it in order to basically denote the risk aversion person, risk neutral person and the risk liking person or seeker person. So, I will use 3 different colors. So, case A. So, if it is a risk seeking, so risk seeking person would be the I will basically denote the utility first also. So, it is basically U1 function. So, in this case the utility 1 of W1 multiplied by half So, this would be true because the sign would be greater than. For the next person, which is risk neutral, I will use the utility of U2. So, it will be U2 of W1 into half plus U1, oh sorry, it will be U2, sorry, my mistake. third one will be C, risk avoider, which will be a utility function U3. I am using the utility function because based on that the person is taking the decision. U3 W1 into half plus U3 into W2 into half is less than U3 C into 1. This value of C which I have written, technically I should replace with W, or because that value should, C is a symbol used for the variable which is certainty value, but still I am using it in order to make you understand. So, what is important is to understand this greater than sign for a risk seeking person, the equal to sign for a risk neutral person or risk indifferent person, and less than sign for a risk avoider. That is point 1. Point number 2 is when a risk seeker is taking that decision which is basically risky, he or she is seeing at the level of value for a risky decisions which will yield an higher value even if the probability is there. So, her or his concern is more to look at the positive side of the output, in the sense he or she thinks there is a chance he or she will get a higher value based on which he or she can take the decision, while a risk neutral person obviously would be indifferent. Now, if you ask me that if a risk seeking person is willing to take the risk, so is there any certainty value which would basically make him indifferent? Answer is yes. So, I will use a color which is let me check, violet. So, violet should do. Yeah. So, in this case the value, I will use the same color for all the 3 cases. So, in this case the value of C based on which the risk taking person will become indifferent would be the case where this value of C increases such that at a certain value, this is new C value which I have written in violet would basically be higher than the C value which is written in red color, such that the expected value on the right hand side increases, hence the equality sign would come. While in the risk neutral person, obviously the equality sign is there, it would not be changing. For the case who is basically a risk avoider, so in this case the C value will decrease, that blue value, blue means what, the value of C which is blue would basically decrease to a certain value such that it will basically be equivalent to the case such that their equality sign for the equation. Now, this would be true along with the fact that the functional form of u1, u2, u3 are different. So, in case if for example, u1 is square root of w and u2 is something else. So, it does not mean that we are trying to basically equate the functional form of u1, u2, u3, they remain as it is, based on that I will be taking the decision. So, I am only considering one person, his or her outlook of risk based on which the decision would be taken. Now, consider I will basically build up the background of the experiment. So, this is a use of uncertainty to find out utility for decision maker, and consider that I do not know your utility function and I want to basically have some idea what your utility function is. So, this is how we will do. We will basically have, and consider this being done very simply theoretically. So, you will understand what I am trying to say. So, you will have basically a graph paper as shown here. Along the x axis I will mark values of W. So, it will be 10, 20, 30, 40, whatever it is, 100, 200, 300. I am not talking about the units, I am only talking about the values. And consider I take 2 arbitrary values A and B, and I also consider a fair gamble such that the probability of getting an chance where the output is A and the probability of the chance for getting the output B is half and half. So, it is a fair gamble. Now, also consider, which is also interesting to note, consider the utility function to be linear, in the sense u w is equal to w. So, if I take a decision and the output is A, my total value for the utility A is u A, which is A again, and the utility when I take the decision which gives me an output of B is u B, which is B again. So, now obviously, in case, just to I am not digressing, I am giving another example. In case if the utility was square root. So, for the decision A, the total utility would have been square root of A, for decision B the utility would have been square root of B. Now, consider that if the utility is basically the same thing, linear one, let me draw a 45 degrees line as shown. So, let us consider the example or the hypothetical methodology how you can find out the utility of a person. So, it can be anything, it can be you, it can be me, whoever it is, I want to find out something to do with the utility function. Now, let us build up the background for that. So, take the slide which is given here and mark along the x axis the values of w. So, they can be w1, w2, w3 or 10, 20, 30, 40, whatever it is, units do not matter, and take arbitrarily any two values a and b, and also consider the outcomes are based for a fair gamble for which the probabilities are half and half. So, obviously, the probability of A coming out is, if I put A is half and probability of B coming out is basically half. To add it on, let us make as another other assumption that the utility function based on which we want to basically draw this graph is linear, which means u w is equal to w. In that case, if u w is equal to w, then the utility of A is u A, which is equal to A again, and utility of B, which is u B, is B again. Hence, the total expected value for that gamble for which the outcomes are A and B is equal to A into half plus B into half. So, let me write it. So, the utility is equal to A into half plus B into half, because A and B have a utility which is going to equal to u w is equal to w. Now, let us draw a 45 degrees line. So, if you draw a 45 degrees line, so the value of A plus B by half would be here, and let me extend it vertically. So, this is the point where it touches the utility, and then let me go on to the left hand side horizontally. So, this is, say for example, some value of some value which is along the y axis, and consider those values which you draw along the y axis are the certainty values. So, consider this certainty value is C1. Now, with this, let us do the experiment, thought out experiment as such. You keep a value of C1 on the table on the left hand side on one side, and you keep a gamble, fair gamble with values of A and B on the right hand side, where the fair gamble probabilities, as you know, are half and half. So, a person enters, consider you enter, and you are asked that there is one certainty value which probability 1 is C1, that is money some sort. What is the units, let us not discuss, it can be anything, dollars, euros, rupees, yens. And on the right hand side you see there are another two values of A and B, and the probabilities are half and half. That means, if you toss and get an head, you get A, if you toss and get a tail, you get B. Now, I ask you that which one would you take? So, you look at these two, case 1 and case 2. Case 1 is basically the certainty value C1, case 2 is basically the fair gamble A, B with probability is half and half, and say for example, you say that you will take the value which is basically the gamble, which now technically means that if the value of C1 would have been little bit higher, like C1 from some plus delta, At some point of time you would have been indifferent between the gamble, which is A into half plus B into half, this expected value, and the certainty value, which is now C 1 plus some delta value. Now, consider the other notion. In case if you did not take the gamble, but you took the certainty value, which means the certainty value should basically decrease, that C 1 should decrease by some value of delta C 1 minus delta, such that the expected value of A into half plus B into half would exactly match the expected value which you are getting from the certainty value, which now is C minus delta. Now, if that is the case, the set of people who are inclined to take the gamble and the set of people who are not inclined to take the gamble, their utilities of the set of decisions would be either above the straight line, which is 45 degrees line, or below the 45 degrees line. So, let us consider how it is true, and that is true. You can basically think that you can understand. If my value of certainty value I want to be low, so it will be C 1 minus delta. So, if I basically go along this x axis, let me take a, so it is some C minus delta. I consider it is some delta minus. So, it will mean at a certain value I would basically be now be equally inclined between the gamble and the certainty value, which is C minus delta. So, if all the values are on the lower hand side, I will basically have a graph which would be on the side below the straight line, and hence it will basically have a risk aversion property. If you remember, I had drawn it graph as this: decreasing, constant, increasing. So, this human being basically would have a utility function which will be like this. In case the person has a utility, let me check the color, light green, where the value of C 1 and the gamble, they are giving me the equivalent which is equal. So, the 45 degrees line would be applicable. So, the human being would basically have a utility function which is W, and for the case if it is above, this is delta and this value is going, which is somewhere here. This would be the curve. So, in that case the values would be the graph here. So, it will be the decreasing rate. So, depending on your characteristics, you can basically ask questions and change the value of C 1 below, go down or go up, so that you are able to plot it. Now, you are asking the question that whether it is possible to change A and B. Yes, it is possible. You change the gamble, the values of A and B, and you can basically plot the different values of C 1 or C 2. So, C 1 is basically expected value of A into A plus B by half. It could be, say for example, A and B now becomes A 1 and B 1. So, it will be A 1 plus B 1 by half, that will be the equivalent of certainty value, which is now C 2, and then you can do the calculations accordingly. Now, on the other questions, you may be also interested to know whether it is possible to change the probabilities, but in this case it is a fair gamble. So, we will consider the probability as half and half only. So, this is the background. So, A and B are the wealth values, that is the values of W. Also for ease of our analysis, we consider that UW is equal to W. You form a lottery such that it has an outcome of A with probability P and that the other outcome is B with probability 1 minus P. Change the values of P and ask the investor how much certain wealth he or she C will have to have in place of the lottery such that he or she is equivalent. The C varies with P. So, we are technically not considering P as to be changing, that P does not become P1, P2, P3, P4 and hence the corresponding probability is 1 minus P becomes 1 minus P1, 1 minus P2 and all these things. We consider P and 1 minus P as half and half only. Now, the expected value of the lottery is now given into P into A, which we consider as half into A plus 1 minus P, which is again half into B. A risk averse person will basically be more inclined towards the gamble and a risk seeking person will be more inclined towards the risk averse person will be more inclined towards the certainty value and the risk seeking person will be more inclined for the gamble. We plot the values of C as they change depending on the changing values of A and B. Probabilities we keep at half and half, and you already have the expected values of the lottery. Based on that you draw it and basically find out whether the concave function, convex function and basically mention some property about the utility of that human being whose utility you are interested to plot. So, how would you find the explicit form the utility function of a person? Suppose you know that it is of the form of the exponential utility function, which is equal to minus e to the power minus AW. You ask the person that given a lottery which has a 50-50 chance of winning, the values are basically 10 lakhs or 1 million and the other value is basically 1 lakh. So, you win 50 lakh with 50% or half a probability 10 lakhs and half probability we win 5 lakhs. In order to buy this lottery, what would he or she will be willing to pay? An answer say for example is 4 lakhs. So, he or she is willing to pay 4 lakhs considering that the probabilities are half and half of winning 10 lakhs and 1 lakhs. It means that the person is indifferent between the certainty value amount of 4 lakhs and the lottery, which is a fair gamble now, because in that case the person will be calculating the fair gamble based on the expected value. So, what would be the expected value? The expected value of the person would be the utility based on 10 lakhs, which would be now minus e to the power minus a into 10 lakhs into half the probability plus minus e into to the power minus a into 1 lakh into half. That value would be equivalent to the certainty value. Certainty value now becomes W becomes now C. So, it will be minus a to the power minus a into C, which is basically 4 lakhs multiplied by 1. So, you equate them. So, if you equate them, what are the only values unknown? If the only values unknown would be A, you will basically do the iteration and find out the values of A accordingly. So, hence you put these values, solving it you will get the values of A and proceed accordingly. So, you can have different type of utilities and do the calculations accordingly. With this, I will close this 47th lecture and continue the discussion further on in the 48th, 49th and 50 related to utility and then come back to the multivariate analysis. Thank you very much and have a nice day.